capacitor, the symbol of two parallel lines. I'm going to put a potential difference V over the capacitor of 1000 volts. So let me put a delta here to remind you that it's the difference between the two plates. As I do that, as I connect the power supply to these two ends, charge will flow on here, and so you will see a very short surge of current. So the ammeter will give you only for the short amount of time that I'm charging, will show you that there is charge flowing, and you will see that. But that's not really the goal of my demonstration. What I'm now going to do is I'm now going to increase the separation, the distance d of these two plates. And remember that the potential difference over the plates, which I call now a capacitor, is the electric field times the distance, and the electric field is constant. If I charge the capacitor up with a certain charge, there is plus Q here, there's minus Q there, and then I remove the power supply, it's no longer there, that charge is trapped, that charge can never change. And so if the charge doesn't change, the charge surface density doesn't change, and so the electric field inside remains constant. So exactly what we did there. And now I'm going to move them further apart, therefore I'm going to make D larger, and that can only happen if the potential difference between the plate increases. And I will start off with 1000 volts, whereby D is 1 millimeter, and then I will open up this gap up to 10 millimeters. And then I have a potential difference of 10,000 volts. But since the energy in the capacitor is 1/2 Q times the potential difference V, this V is the same as this delta V. And if Q is not changing, but if I go from V from 1,000 volts to 10,000 volts, it's very clear that I have done work. I have increased the electrostatic potential energy. And this is what I want to show you. We're going to have that there. So I've changed my television, and I'll have to change the lights a little bit so that you can see that. Well, turn this one off, and all dim. Let's wait for the light to settle, and we want also the current meter. So the one on the right there is the amp meter, the current meter. And you see here, these two plates, they are separated now by about 1 millimeter. I have here a very thin sheet transparency, which I can move in between to make sure that they don't make contact. And here is my power supply, and I have there this propeller type thing, which is some kind of a voltmeter. And if it's going to move in this direction, that means that the voltage between the plates increases. And so I'm going to charge it now. There's a potential difference of 1000 volts. And as I do that, you will see a very short surge here on this ammeter. That's not very spectacular, but at least you can see for the first time in your life that charge is actually flowing from my power supply onto the plates. And you will see, psh, and that's it. It will only be a current as long as the charge is flowing. So let me first do that. Look at the ammeter there. 3, 2, 1, 0. That's all it took to charge this plate. It's now fully charged. 1000 volts difference. And now, as I'm going to increase the gap, there's no reason for any charge to go away from the plate, so the ammeter will not do much, probably nothing. But you're going to see this propeller, which indicates the potential difference between the plates. You're going to see it move because I'm doing all this work. I'm going from 1 millimeter to 10 millimeters. I'm creating all these electric fields, and this hard work pays off in terms of increasing the potential from 1000 volts to 10,000 volts. So there I go. I'm 2 millimeters now. Look at the voltmeter. There's going 3 millimeters. I'm doing all this hard work while you're doing nothing. 4 millimeters. I'm creating electric fields. You should be proud of me. I'm creating electric field. Look at that. The electric field remains constant between the plates because the charge is trapped. The charge can't go anywhere. I'm now at 7 millimeters, 7,000 volts, 8,000 volts. I'm at 9 millimeters, 9,000 volts. Notice that the ammeter does nothing. No charge is flowing to the plates. No charge is flowing from the plates. I'm now at 10 millimeters, and now I have created a huge volume, electric field, and the potential difference is 10 times larger than it was before, and so you see that I indeed have done work. You see it here in front of your own eyes. All right, let's get this down, and I'll bring the lights back up, and we go back to normal. I have here a 100 microfarad capacitor. It's a dangerous baby. And we can charge that up to 3,000 volts. And when we do that, we get 0.3 of a Coulomb of charge on that capacitor. So I'll give you some numbers. So it is 100 microfarad. I'm going to put a potential difference over it of 3,000 volts. That gives it a charge Q of 0.3 Coulomb. And that means that 1/2 CV squared, which is the energy that is stored then in the capacitor, is 450 joules. And this will take 15 minutes. And so I'm going to charge it now, because at the end of the lecture, I need a charge capacitor for a demonstration. And so I can show you there the potential difference over the capacitor, which will slowly change. And we'll keep an eye on it during the lecture. And then by the time it's fully charged, we will have reached the end of the lecture, and then we can continue. So here is then this monster, the 100 microfarad. I call it a monster because the amount of energy that you can pump in there is frightening. It's 450 joules. And my power supply is here. That would deliver comfortably the 3,000 volts. In fact, this is the voltage of the power supply. This is about 3,800 volts. And so now the idea is that I'm going to charge this capacitor. Always have to be very slow and careful that I don't make mistakes, because this is really a device that could be lethal if you are not careful. So I think we're okay. The moment that I'm going to charge this capacitor, the reading there will show you the potential difference over these plates, and it will take a long time for that to go up to 3,000 volts. And so I think I'm ready to go, and I'm going to charge it now. So you see now that the potential difference over the plates is very low, it's near zero, but if you wait just a few seconds, you will see very slowly that